So I had somebody ask about question 12, and they made a brilliant mistake, which is so close to being right, but is not quite right. And so looking at number 12, we've got a function and we want to find the tangent that passes through the origin. And so when you hear the word tangent, you think, okay, let's take a derivative. So f prime of x using the chain rule is going to be 1/2 times e to the x over 2 minus 1. E to the x stays the same. Chain rule, you multiply by the derivative, so that's where the 1/2 came from. And then the mistake they made, really good idea, is, origin means x equals 0, and so they said f prime of 0 is 1/2 e to the 0 over 2 minus 1. And going through that and getting f prime of 0 equals 1/2 e to the negative 1. In other words, f prime of 0 equals 1 over 2e. Now, what you know with this is you know that this is the tangent line at x equals 0. And in fact, because this is an exponential graph, I can draw it like this. This is a really rough version of the exponential graph. And I know also that it has an asymptote at y equals 0. So finding the tangent line at x equals 0 is guaranteed to not go through the origin. And so that does not actually meet up with what the question is asking for. This equation right here would be y equals 1 over 2ex plus, and then if I plugged in x equals 0, I would get e to the negative 1. So that would be the y-intercept. So it doesn't go through the origin. I really like that mistake, though, because you're thinking, tangent, derivative, origin, plug in 0. But the question says to find the tangent that passes through the origin. Okay, so instead of plugging in f prime of 0, what I'm going to do is I'll go to blue for this one. I'm just going to use this derivative, and I'm going to set up a y equals mx plus b equation. And if it passes through the origin, I know my b is going to be 0. So really, y equals mx. And then I need it to pass through the origin, and I need it to touch the curve right here. So I'll plug in the y value of the curve. I'll plug in the m value from our derivative. And the m is multiplied by x. So we have this situation right here. And what I notice is that both sides have the same e to the x over 2 minus 1. And so I can divide both sides by e to the x over 2 minus 1, divide by e to the x over 2 minus 1. Let's move my little face out of the way. And then what's really nice about that is it cancels out to leave you with 1 equals 1/2 times x. So what did we just figure out here? We figured out that when x is equal to 2, our tangent line goes through the origin because we did a plus b of 0. And so when x is equal to 2, that's where you will find the tangent line that goes through the origin. And so what we need to do is find f prime of 2, which is 1/2 times e to the 2 over 2 minus 1, which ends up being 1/2. And so our second tangent line is going to intersect right here at x equals 2. You can see how that goes through the origin, and it has a slope of 1/2, and so that tangent line is just y equals 1/2 x. Okay, so just wanted to point out a brilliant mistake and then one approach to finding the correct tangent line that goes through the origin. There you go. Please keep the good questions coming and the good mistakes.